Page 263, lesson 5.2 is on solving systems by graphing. So the question is, how does the graph of a system of linear equations represent its solution? So in the previous section, we were more just analyzing the slopes and the y-intercepts and telling whether we were going to have any solutions or not. In this section, we're going to be looking at graphs and actually finding what the solutions of the system of equations are. Some of the stuff in this book, it's not always going to work out as nicely. Also, when you try to graph things, if your lines are not perfect, then your answer, your solution of where those lines intersect might not be exactly where it should be. So especially next year, maybe at the end of the year, this year as well, we'll get into a little bit of how we can solve systems algebraically. We can actually work and solve by hand where the lines are going to intersect each other. And that'll be a more accurate way of doing it, because when I'm drawing lines, you know, if I have a ruler and I'm being really careful about things, maybe I can get my lines to match up, but it's not always guaranteed. Also, the intersections of the lines don't have to be a nice number. Like if I have two lines that I'm graphing, if I graph two lines, we try and find the solution. I mean, these lines could intersect at the point 2 1/4, 3 9/10. There's no way I'm going to be able to tell that that's the intersection point by looking at my graph. Okay, so that's why long term it's actually going to be more accurate way if you guys work these out by hand, which is again what you guys will learn more next year or maybe at the end of the year this year. The stuff they're giving us now, the problems they're giving us, should come out nicer than that. Okay, maybe it'll come out as 2, 3 instead of that. But for that reason, we'll talk about stuff a little bit here, but then we'll actually be looking at doing some problems on the computer to get some practice, and that'll actually be more similar to what you'll be doing when you take the iLearn test anyway. So if we look at example 1, Lee is choosing a new cell phone plan. How can Lee use the graphs of a system of linear equations to determine when the phone plans cost the same, and which plan should Lee choose and explain? All right, so you can see from the information here, Company A is 20 cents per minute plus $75, and you get unlimited data. Company B is 25 cents per minute, and it's $70 for unlimited data. Okay, now this seems a little bit weird because you're paying per minute, but then the unlimited data, usually the unlimited minutes comes before unlimited data, but anyway, this is what these companies are doing apparently. So first thing they did here is define the variables. Rather than x equals, probably would be good to say represent. Okay, so let x represent the number of minutes used each month. Let y represent the total monthly costs. So the costs for Company A would be 20 cents a minute times x plus $75. Notice the 20 cents they put as 0.20. Since 75 is in dollars, we want the 20 cents to be in the dollar format as well. And then Company B is 25 cents times x plus $70. So these are our equations. Based off of this, we could think about what we did yesterday, and we could already determine how many solutions we would have to this system of equations. So like we talked about in the last lesson, first thing is I would look at the slopes. This one has a slope of 0.20. This one has a slope of 0.25. The slopes are different, means we are going to have one solution. The lines are angled different. They're going to intersect in one point. Okay, so we are going to have one solution. The solution actually is going to tell us where the cost would be the same. Either way, Company A, Company B, the cost is going to be the same, whichever one we get. So if we were going to do this way, probably what I would do is put in a 0 for x into this equation, and you get 75. We're probably going to talk quite a few minutes. So, maybe let's say 100 minutes and see how much that costs. So if you do 0.20 times 100, that's just going to move your decimal over 2 spots. That'd be $20 plus 75. That'd be $95. Would be another point on that graph. And we could find another one as well. You can look over to the side. The graph's already there in your book. So, maybe we go with 300 minutes. So we could work that out. Would be 20 cents times 300 plus 75. So that would be, so 60 plus 75, that'd be $135. Okay, so those would be 3 points that would be on that line. On the other line, if we put in a 0 for x, that would be 70. Maybe we just do the same thing, so 100. If you do 0.25 times 100, moves your decimal 2 spots, that'd be 25. Plus 70 would be 95. And then let's see for 300 minutes. So 300 times 0.25 is 75 plus 70 would be 145. Okay, so this is not a very common thing. This is called blind luck, you could say. We had, if you look at our numbers here, both of them have 195. So we actually found the solution just by listing these points out. We already know what the solution is, and that's not normally going to happen. Normally what we'd have to do, we find our points and then we graph the equations, and then we would be trying to look at our graphs to tell where they intersect each other. So my argument against having you guys do all these problems in your book is that if you graph this, realistically, let's look at this graph. If we didn't know 195 was a point on both of those graphs, there's no way I would be able to tell that this point is 195. I got the 100, but how in the world did they tell that that's 95? This is halfway in between 80 and 120. This would be 100. So yeah, it's a little less than 100, but how do I know it's 95 and not 97, 98, 92, 93 and a half? There's no way I'm going to pinpoint that at 95 unless it was already one of my values that I already found. Okay, so again, that's just my argument, and that's why we're not going to do as much stuff in your book with some of these problems. And again, there's a way we can work it out by hand that's going to be a more accurate way to find for sure that solution we'll talk about later. But this is your 8th grade standard. This is what you guys are supposed to learn about, is graphing lines and looking at where they intersect. So we'll keep with what they're wanting you to learn at this point, but just understand there's a better way down the road that you'll be able to learn that's going to be easier to always tell what the answer is going to be, even if it doesn't come out evenly. All right, so anyway, from the graphs, you can tell they intersect at 195. That is the one solution, which means that if she uses 100 minutes each month, either plan is going to cost $95. So at that point, it doesn't matter. If you look at the graph, you can see company B to start with is a little bit lower. So if they used less than 100 minutes, company B would be cheaper. If they used more than 100 minutes, notice company A is the lower line. So more than 100 minutes, company A would be a better plan for her, a cheaper plan. We look at the try it. They want us to solve this system by graphing. First of all, like we did in the last lesson, we can look at the slopes. Notice the slopes are different, so we are going to have one solution to this problem. There will be one solution. And so it's just a matter of figuring out what that solution is going to be. So if I were doing this problem, then what I would do is we can take our equations here and we can find some points that would be on these graphs. So we've talked about before, when we're doing these, we can make an X and Y chart. If it's already solved for Y, we've talked about when it's a Y equals, that we can use X values of 0, 1, and 2. Those are just nice small numbers that we can substitute and see what we get here. So if we have X equals 0, we got 3 times 0 is 0, plus 5 is 5. You can have a middle column if you want to work this out, but I kind of just feel, I kind of just like working it over to the side. I feel like I've got a little bit more space to work maybe. If we put a 1 in for X, we got 3 times 1 is 3, plus 5 is 8. And if we put a 2 in for X, we got 3 times 2 is 6, plus 5 is 11. So those would be 3 points on that graph. And then we can do the same thing with the other equation. Before we look at that other graph, if you'll notice, or the other equation, notice the graph is going from like -5 to 5 on the x's, -5 to 5 on the y's. So on the x's, that's no problem. On the y's, we've got a little bit of an issue because we have a y value of 8 and a y value of 11. Those values, that's going to be, those 2 points are going to be off the charts. And so what that means is we would have to pick different numbers that would actually fit on our chart. So if you'll notice, our y values are getting bigger as we go with bigger x values. So we need to instead use some smaller x values. Okay, so it would be good maybe to try -1 and -2 as our x values. That will give us smaller y values in this case, since the slope is positive on this graph. So if we put in a -1 in place of x, 3 times -1 is -3. -3 plus 5 is 2. That's going to be a nicer point for us to graph. If we put a -2 in place of x, we'd have -6 plus 5, which is -1. Okay, so actually, these last 2 points that we came up with, and then the 0, 5, those would be the points actually we would want to graph. And the thing is, if you guys were doing this like on Khan Academy or on iLearn test, you're not going to be able to change their graph. So you can't just, if we could draw our own graph, from scratch, that would be ideal. And then we could make it be whatever numbers we wanted, but that's not the case. So we do have to fit points to what works on the graph that they've given us. So if we look at our other equation, it's going to be kind of the same thing here. We're going to try to pick some points. We'll try to be a little more mindful this time about whether these points are going to actually fit on our graph or not. So if we put in a 0 for x, we got 2 times 0 is 0, plus 4 is 4. Put a 1 in for x. 2 times 1 is 2, plus 4 is 6, so we've got 1, 6. 1, 6 is already going to be off the chart, and this has a positive slope. See how the y values are increasing? We don't want to get higher y values. We want to get lower y values than that. So we're going to have to shift gears here a little bit and go with something smaller. And I'm kind of boxing myself in. I've kind of painted myself in a corner, so to speak, here. So I don't have enough room to write these underneath because it's pulling that page along with it. So I'm going to come over to the side here. We do want, just like we did on the other one, we want to pick then smaller x values. Since the bigger x values weren't working, we'll try some smaller x values, and that should fit on our graph hopefully. So we're going to put a -1 in place of x. So this would be -2 plus 4, which would be a +2. So that should work on our graph. And then we'll put a -2 in for x. So that would be -4 plus 4, which is 0. Okay, I know when you do these, this is a little bit of a process. I know that's a lot of stuff to write out, but that's really what we need to do, okay? Some of this stuff here, it's not necessarily difficult, it's a little tedious, you could argue. And once again, you aren't going to believe me because we've done it now twice in a row, but this really doesn't happen that often that we find our solution by the points that we picked. Notice both of these have a -1, 2, -1, 2. -1, 2 is going to be our solution on this equation then. Okay, so if we graph these, so first equation we had 0, 5, -1, 2, and -2, 1. Sorry, that last point should have been -2, -1. I was noticing my points weren't lining up with each other. And then we can draw a line through those points. And then our other equation, I'll do in a different color here. We had 0, 4, -1, 2, and -2, 0. And I'm using a ruler function. It looks really professional there because you can't see my ruler, I don't think, but I was actually using a ruler to make that straight line. So that's something you can do. That's probably a good idea, using a ruler or using the side of a piece of paper if you don't have a ruler handy, to make that a nice straight line. So the solution is where these intersect, which would be, like we said, at the point -1, 2. So if we were filling the box in there, we would say -1, 2 is our solution. So again, make sure if you were doing a problem like this, it's good to look at what their graph is if they give you a graph, and make sure ahead of time, like I didn't do to start out with, make sure that your points are actually fitting on the graph. If they're not, you're going to have to just pick different x values. So look at example 2. They want us to solve this system of equations. If we were doing this, you could take the second equation since it's not solved for y, and you could just find the intercepts, but we'll just go through it like we've been doing these other ones. We'll go ahead and solve the equation for y. So the first equation, notice, has a slope of 1. Y-intercept is -4. You can add the opposite there if you want. So kind of what we're going to do here by solving for y, that's going to help us determine how many solutions we're going to have. And that's going to help us decide what our graphs should be looking like. So we're going to try to get our y term by itself. In order to do that, we've actually got a positive 2x in front here. To get rid of a positive 2x, we need to subtract 2x on both sides. When you do that, remember this is a -2y. Don't lose that sign in front of that. And those are not like terms on the other side, so I'm going to put it as -2x minus 2. And then finally is we're going to divide everything by -2 to get the y by itself. When we do that, negative divided by negative is a positive, so that would be 1x, and then -2 divided by -2, negative divided by negative is positive, same thing basically. So we should end up with y equals 1x plus 1. Our other equation is y equals 1x minus 4. So if we analyze that like we did in the last section, you can see that the slopes are the same. Y-intercepts are different. So that tells us that the lines are parallel, which means we have no solution. So if they ask us to graph the lines, we could graph the lines, but they are not going to intersect each other actually. And you can see that in the book here. In this case, we would probably be okay. Excuse me. We would probably be okay picking 0, 1, and 2. I think all of those values would show up. So 0, 1, 1, 2, 2, 3, 0, -4, 1, -3, 2, -2. Okay, and those lines would be parallel. It's nice to have this figured out ahead of time that we know they're going to be parallel, so we're not looking for an intersection point that is not there. Okay, or if our lines aren't perfectly straight, we're going to know, wait a second, these lines actually shouldn't be intersecting each other. So we'll continue looking at solving systems of equations by graphing later. Have a good day.